This lesson is for Advanced Algebra, Lesson 10.1 and 10.2. We're going to learn something today called SohCahToa. It is an acronym that we use for trigonometric ratios. And trigonometric ratios are when we use sine, cosine, and tangent. Those are called trig functions or trig ratios. And we use those ratios for right triangles only. Then when we get into lesson 10.2, we're going to just do a little bit more with SohCahToa using inverses. So let's start out by just looking at a right triangle. We can tell that it's a right triangle because the corner here behaves like an arrow that points to the hypotenuse side. So the hypotenuse is the longest side of a right triangle, and it's pointed to by the right angle or the 90-degree angle. The other two parts of the triangle are called legs. Depending upon which angle you're working with, you might call those legs with an additional name. So let's start out by looking at the SO part of our acronym. The letters in the acronym help us remember all the different relationships for the three trig functions that we're going to look at in this video. The first one is S, which stands for sine, S-I-N. Technically it's written out as S-I-N-E, we just abbreviate it to just 3 letters long. You always do sine or cosine or tangent of an angle, so let's call this angle X down here. So that angle is formed by those two lines. And then we would need to find the sine of that angle, we would need the opposite leg and the hypotenuse side. And so if we divide those together, that'll give us the sine of the angle. So the opposite leg to this angle would then be this leg over here, because it's across from it. This angle and that leg are across from each other. The one down here is right next to that angle, so we'd call that the adjacent leg. Adjacent is another word for next to. And then obviously the hypotenuse is this side here. If we utilize that same angle and do the CA part of the acronym, the C stands for cosine, normally spelled like this. And the cosine of that same angle would be a completely different ratio called the adjacent leg divided by the hypotenuse. So you would take different pieces to identify the sine versus the cosine. Please don't say cos. Okay, make sure that you pronounce it correctly. It should be cosine, even when it's abbreviated COS. The last one we're going to look at is tangent. That's the TOA part of the acronym. T stands for tan or tangent. So that one's easy to pronounce because it's pronounced just like what you would normally say. And then we always do of an angle. And for TOA, we do the opposite leg over the adjacent leg for its ratio. So we would do this side divided by that side. So clearly all three give you a different ratio, and so you can use all three to find different things on your triangle. Keep in mind that if we switched to this angle up here as our angle that we're working with, now all of a sudden the opposite and the adjacent legs would be switched or mislabeled. So if this were the angle we were working with, let's call it angle A. If I were trying to find the sine of that angle, now the opposite leg would now be over here. So the relationship between the angle that you're working with and the legs is very important for students to identify. Figure out which angle you're working with and then start labeling the legs as opposite or adjacent. So now if angle A was the one we were working with, now this would be the adjacent leg. So let's go ahead and try this now with some actual examples. Before we get there, just want to be real clear with students on how to name the sides of a triangle. When you're working with a triangle, capital letters are going to be the corners or the angles. So I'd use ABC here to indicate the corners or the angles. Then the sides are lowercase letters across from the angle that goes with it. So if I were trying to place side little a, it has to be across from side big or angle big A. So little a has to be on this side here. Little b would have to be down here, and little c would have to be across there. Now those, it's kind of hard to distinguish which one's big or little, but hopefully you get the idea there. Make sure that you're in degree mode on your calculator. This is super important. I would recommend for students not to use the scratch pad on their Inspire calculators because the scratch pad tends to be problematic in terms of which mode it's in. I've helped students fix their scratch pad so that it's in the right mode, and then the next time they turn it on, it has switched back to a previous mode that we don't want. So I'm going to show you real quickly here how to set up a document on your calculator that you can save and go back to that will always be in the right mode. So grab your Inspire calculator, and I want you to start a brand new document. So you're going to go to the home screen. Don't use these tabs down here. I want you to actually select New Document with your arrow keys. It may or may not ask you to save a previous document. That's up to you if you want to save or not. Add a calculator page, and I want you to type in cosine of 90. On this calculator, to get to the cosine buttons, you'll have to hit the trig button and then choose cosine, and then just type in a 90. Hit a Control Enter to go ahead and get an answer. Now if you get an answer like mine, that's not the correct answer. It's supposed to be cosine 90 is 0, and we'll talk about why the answer is 0 later on in this chapter. If you get a negative 0.44 like I did, you're in the wrong mode. So we need to change the mode of this document, and then we're going to save it so that it's always in that right mode. So to change the mode, you're going to go to the document button. Excuse me. You're going to go to Yes, the document button is what you go to, and you should get a file that, or a pop-up window that looks like this. We want to go to Settings, and then either Settings or Document Settings, and then choose General. The second one down should say Angle, and the one that we want there should be Degree, not Radian. Then go all the way down to OK. Now when we do cosine 90 and a Control Enter, we should get the value 0. So I want to know that this document is now in the right mode, and I want to save it. So let's go back to the document button, hit File, Save, and just call it Degree. I'm not going to actually save it that way because I already have a document ready to go, but that's what you would do, is call it Degree, hit Save. Then when you go to your home screen one more time and go to My Documents, you'll be able to see that one of your documents there is the degree document that you're looking for. So then you can just open that and know that it's always going to be in the right mode for you. It even says degree at the top now that we've saved it with that name. That way there's no surprises moving forward. So now let's go back to our notes and let's try some problems together. If you're given this triangle, know, students, that I do not draw these accurately. I literally sketch them and I fill in numbers. So they may or may not be accurate in terms of their length or the angle measures. You can see here that the 90-degree angle is pointing to the 510 side, so that means this side is the hypotenuse side. So I'm going to go ahead and label it that way. Then the 50 and the side that's been marked with a question mark have a relationship, and I need to figure out if that relationship is opposite or adjacent. Is this side opposite or adjacent this angle? It's indeed opposite. If I were looking for the adjacent side, it would be over here, but there's nothing there. There's no label, so I'm not even going to worry about putting anything on this side because I'm not looking for it. Now you look at your acronym. The acronym that involves the O and the H at the same time or right next to each other is the SO part of the acronym. So that means I'm going to set up a sine problem here. So I'm going to set up sine. It's always of the angle, and then you do opposite over hypotenuse. So in this case, opposite is the piece that I don't know, and the hypotenuse was given to me as 510. Now you're going to use your algebra skills to solve for the question mark. To get the question mark alone, we would multiply on both sides by whatever's on the bottom of that fraction. Now you'll just simply type it in. So I typed in 510 sine 50, and I'm going to hit a Control Enter to get a decimal answer. I get about 391 if I round to the whole number. So I'm going to say 391 approximately. And that answer is reasonable because I have a hypotenuse length of 510, so I know that any of the legs are going to be smaller than that. Let's try another one, the one right next to it. So I've got this angle and two sides that are pretty much right next to it. So I've got to figure out which one is the adjacent side. First I'm going to identify my arrow, which points to my hypotenuse side. That must mean this side here is the adjacent side. Both sides are adjacent to the angle, but the hypotenuse name takes priority over the adjacent name, so we usually figure out that one first. Now let's set up a according to our acronym, either sine, cosine, or tangent that involves a and h at the same time, or right next to each other. So you're right, it's a cosine problem. Always do cosine of the angle. Then you set up a over h for the ka part of SohCahToa. So the adjacent side is the 85, and the question mark side goes on the bottom. I cannot solve for the question mark when it's on the bottom, so the first thing I need to do is move that by multiplying by it on both sides of my equation. So I've got cosine 30 now times the question mark equals 85. To try to get that question mark or that variable alone, I need to divide by cosine 30 on both sides. The cosine 30 on the left is going to cancel. Over here I'm just going to divide that out. So I'm going to hit 85 cosine 30, and I hit a control enter to solve, and I get about 74. Got one more problem to try here, and I realize now that the calculator didn't cooperate with me there. That shouldn't have been a 74 because I needed to divide there, so it should have been 85 divided by cosine 30 to get a 98. Sorry about the mistake there. Just a little calculator glitch. Let's go ahead and try the last one now. Might be able to predict a little bit. We did a sine, we did a cosine. Probably a good guess here that we're going to get a tan problem, but let's make sure. So if we go ahead and set up what we have and start labeling everything, the 26 and the 16 are definitely adjacent to each other. 26 and this side are definitely across from each other or opposite of each other. So yeah, it looks like it will be a tan problem. Tan of the angle is equal to opposite over adjacent. So I'm going to say question mark over 16. Multiply on both sides by 16 to get the question mark alone. So 16 tan 26 is my answer. I want to point out to students that you don't want to do tan 26 times 16 this way, because then it's confusing for people and for your calculator to figure out, should you do the tan of 26 and then multiply your answer by 16, or do you mean 26 times 16 and then the tan of that? So putting the 16 in front just makes it so much easier. Then you don't have to worry about what to do with multiplying or using parentheses at all. So this way we just type it in as is and there's no confusion. So 16 tan, and again I'm having, there we go, 16 tan 26, hit a control enter to get a decimal, and let's just say about 7.8 there if we were rounding to the 10th. Now let's talk about something that you would need to do from lesson 10.2. In 10.2 you're finding a missing angle. When you're finding a missing angle you will have to use an inverse. And I'll show you what an inverse looks like. If we're trying to find the measure of angle x first, just because it comes first alphabetically, if all the other sides are given, then we have the option to use any of the three trig functions that we want. Most of the time kids like to use sine because it's the first one in the acronym, but know that you could use cosine or tangent here and it would still work. It's sine of the angle. We don't know the measure of the angle. And then we need to find, for sine, it's always opposite over hypotenuse. So opposite of angle x is side 3, and the hypotenuse side is side 5. So now how do I solve that for x? A lot of times students think that they need to multiply by 5 here, and that will not help you. That actually adds more things to the side where the x is. We need the sign to go away. So what we're going to do is input an inverse sign. It looks like the sign is being raised to the -1 power, but really all we say there is inverse sign. Let's move our fraction over a bit so that we've got some room to put in the inverse command. So I'm going to say inverse sign and then my 3/5. So the 3/5 was there, I just slid it over a little bit. On this side, the inverse sign and its original function will cancel. Over here I just type in inverse sign of 3/5. On the calculator, I'm just going to choose inverse and then 3 divided by 5. Or if you want to use the fraction bar, that works as well. So I get about 37 if I'm rounding to a whole number. Be careful to put in the degree measure, because because it is an angle that we just found. Now keep in mind that if you are asked to find angle y as well, you can use your geometry skills from here. I know that all the angles in a triangle add up to 180. So if I say 180 minus the 90-degree angle that's already there, minus the angle that I just found, that should tell me the remaining angle. So that would be 53 degrees for angle y. Moving on to some word problems. The word problems here will involve either an angle of elevation or an angle of depression. In both instances, they come from a horizontal. An angle of elevation will come from a horizontal and go upwards. An angle of depression will come from a horizontal and go downwards. The good news is that no matter which one you're working with, they are equal to each other. And the reason for that is because of a property you learned back in geometry. The two angles that I just marked here are called alternate interior angles because they're on alternate sides of a transversal and they're on the interior of two parallel lines. Alternate interior angles are equal. So if you are working with an angle of depression, but you need the angle of elevation, know that those are going to be identical to each other. So the same thing is true here. Here we have an angle of elevation. Here we have an angle of depression. In either case, the two angle measures will be the same. So let's put that into practice now with a word problem. You will have word problems on your next quiz. If a flagpole casts a shadow 24 feet long and the angle of elevation from the ground to the top of the flagpole is 25 degrees, how tall is the flagpole? So obviously a flagpole works much better when it's perpendicular to the ground. Here's my crude attempt at drawing a flag that's flapping in the breeze. The shadow will either be cast to the right or to the left. I'm going to put mine back to the left. The shadow will actually be on the ground. So the shadow here is 24. Flagpole's perpendicular to the ground. I need to know how tall it is and then where the angle is. It says that the angle is 25 degrees and it's an angle of elevation. The only horizontal piece is down here. If I angle up from there, I have my 25-degree angle. Based on my picture now, I should be able to determine if I'm using sine, cosine, or tangent. Related to this angle, I've got the adjacent side marked, and I'm trying to find the opposite side. So the part of SohCahToa that involves opposite and adjacent is tan. If you try to do this problem with sine or cosine, it will not work because you don't have a hypotenuse. Sine and cosine are not going to work on this one. So I'm going to do tan of the angle, and then I do opposite over adjacent. To solve for x, I would multiply on both sides by 24. And so then you'll type that in on your calculator. And you should get about 11 when you do that. Let's try one more here. This time it's a person on top of a building finds that there is an 87.14 degree angle of depression to the head of a 6-foot tall assistant. If the assistant is 40 feet away from the building, how tall is the building? So the person standing up here, looking down at an assistant, and be careful here because it does say to the head of the 6-foot tall assistant. So there's 6 feet there that we need to make sure to add on to the end when we're done. So the person standing at the top of the building, we don't know how tall the building is, but we do know that the person at the ground is 40 feet away. Then we've got an angle of depression this time. The angle of depression is actually right here. It always goes from a horizontal downwards, and that angle is not part of our triangle. Our 90-degree triangle is right in here. The good news is this angle is the same as this angle here. So I'm going to name that angle 87.14 degrees. So it's going from there to there. Now I'm going to label opposite, adjacent, hypotenuse, and all of those to figure out what part of SohCahToa I'm going to use. Related to this angle, I've got the opposite side, and that x should actually stop here. Got the opposite side for x, and adjacent to this angle is the 40. So opposite and adjacent again. Looks like we're using a lot of tan today. And then I need opposite over adjacent, so that's going to be x over 40. Multiply on both sides by 40 and then add the extra 6 feet onto the assistant. Our triangle that we used only went to the head of the assistant, it didn't go all the way to the ground. So we have to add in the height of the assistant at the end. So with rounding there, when I type in 40 tan 87.14 plus the 6-foot height assistant, I get about 807 feet if I round to the whole number. This next problem that I'm going to demonstrate is in, I believe, lesson 10.1 homework. It was not covered in class. I wanted to help explain for students problems that involve regular polygons. If a polygon is regular, all the angles and all the sides are going to be equal. And I took this example right out of your book, page 666. It's example 3. If you have a regular pentagon, that means all these angles, angle I, angle V, angle A, and so on, are all the same measure. They want us to find the length of V sub O, or excuse me, VO here, it's a diagonal. If all the sides of the pentagon are the same, and they are all 7.8, then what I can do is figure out what the angle measures are, because it's a regular polygon. In order to do that, we have to review a formula from geometry. And that formula is n minus 2 times 180, and then we're going to divide that by n. N represents the number of sides of the figure. Since ours is a pentagon, that means 5 is the n value. So if I do 5 minus 2, I get 3. 3 times 180 divided by 5 gets me 108. So the top part of this formula tells me all the angles added up. If I divide by however many angles there are, that tells me what one angle would be. So I know that angle I is 108 degrees. That doesn't really do me any good right now, but what I can do is cut this triangle that's formed in half. As soon as I do that, now I have a right triangle. So that's what's been drawn here. So it was this triangle here that got redrawn, and this triangle here. So if 108 was the whole angle, if I cut it in half, now just this half of it will be 54. And I've got a right triangle formed there. So they introduced a new coordinate here called P. So now we're just going to utilize this triangle to come up with the answer that we're looking for. The answer we're looking for is this length. Now we need it to be this length as well, but we know that that will be just double whatever we get. Related to this angle, this side is opposite, and this side is the hypotenuse. So we would set up a sine problem here. Sine 54 is going to be equal to opposite over hypotenuse. Multiply on both sides by 7.8. And you get about 6.3. Make sure that you double it though, because that's the entire length. So it's going to be around 12.6 depending upon what you round to. And then it looks like this was in centimeters, so make sure you label it with centimeters. The last thing I want to look at is the book mentions something called exact values from page 667. It talks about a review item from geometry, the 30, 60, 90 triangle and the 45, 45, 90 triangles. Those are pictured here. If you would like to copy them into your notes, you may. And so it just talks about how the relationships among the sides are always going to be the same regardless of how large or how small these triangles are drawn. The benefit here is that eventually, when we get to items later on in the lesson, later on in the chapter, we'll be able to come up with answers like what is the sine of 30, sine of 60, or the sine of 45, and we'll be able to come up with exact values for those. If students aren't understanding what these are for right now, that's okay. We will be revealing more of that later on in the chapter.